Okay, let's try some verifying questions. 39. Sine theta plus cosine theta times cotangent theta is equal to cosecant theta. Every time you verify trigonometric equations, you have to change one side only. So keep the other side as it is. Usually you better choose more complicated side to change. So for this question, I'm going to change left side. Sine theta is just sine theta. Cosine theta is just cosine theta. You cannot change them because they are basic expressions. Cotangent, yeah. You change cotangent theta to cosine theta over sine theta based on quotient identity. The other side should be same. And then you simplify. Right. Sine theta is sine theta. Cosine theta times cosine over sine. Cosine times cosine is cosine squared theta over denominator is sine theta equals cosecant theta. Now I'm going to add these two. To add those two fractions with two different denominators, we need to keep same denominator. I mean, you need to set up common denominator, which should be sine theta. So in first term sine theta, you should make sine theta and sine theta times sine theta, sine squared theta. I multiply sine theta in denominator and numerator. And then the other fraction has cosine squared theta over sine theta. Right side is same. Now you can add these two, right? Because denominators are same. So numerator is cosine squared theta plus sine squared theta plus cosine squared theta, which is 1. Based on first Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. Denominator is sine theta. The other side is cosecant theta. 1 over sine theta should be cosecant theta based on reciprocal identity. So cosecant theta equals cosecant theta. Next. Yeah, number 40. Secant theta minus tangent theta times cosecant theta plus 1 equals cotangent theta. A little bit more complicated. Yeah, we better change left side because left side is more complicated. Secant theta is 1 over cosine. Tangent is sine over cosine based on quotient identity. Cosecant is 1 over sine. 1 is like sine over sine because we need common denominator to add these two. Cotangent theta. All right. In first two fractions, you can do subtraction because cosine theta is common denominator. So 1 minus sine theta over cosine theta. The other fractions, 1 plus sine theta over sine theta. Right side should be same. And then you multiply these two different fractions. So denominator is cosine theta times sine theta. Numerator 1 minus sine theta times 1 plus sine theta. It's like a minus b times a plus b form. 1 minus sine times 1 plus sine. So it's going to be a squared minus b squared. This is one of the three special cases. So if you multiply numerators, 1 minus sine theta times 1 plus sine theta is going to be 1 squared minus sine squared theta. Right side is same. Okay, now I'm going to change numerator. According to first Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. And then you move this to the other side, switching signs. So cosine squared theta is equal to 1 minus sine squared theta. you can replace numerator with cosine squared theta according to first Pythagorean identity. So cosine squared theta over cosine theta times sine theta in denominator equals cotangent theta. And then you divide in first fraction in left side. You can divide the numerator and denominator by cosine theta. So 1 cosine theta cancel out, 1 cosine theta cancel out. So numerator is just cosine theta, denominator is sine theta, equals cotangent theta. According to quotient identity, cosine over sine is equal to cotangent theta. So we can make cotangent theta equals cotangent theta. And then 41. Cosine theta over 1 minus sine theta is equal to secant theta plus tangent theta. Which side do we need to change? Left side? Right side? Let's change right side. Secant is 1 over cosine. Tangent is sine over cosine. So you can combine these two because cosine theta is common denominator. 1 plus sine theta. Left side are same. Do not change both sides. Okay. We need to keep on changing right side. But in right side, there is one fraction which is composed of basic functions, sine and cosine. So looks like there's nothing to change, right? In that case, you should multiply the expression which is like conjugate of numerator, because numerator is binomial. There are two terms. So you multiply 1 minus sine theta in this case. 1 minus sine theta in numerator and denominator. You can multiply same expression in numerator and in denominator fraction. So numerator is 1 plus sine theta times 1 minus sine theta, which is 1 squared minus sine squared theta. Denominator, just keep it. Cosine theta times 1 minus sine theta. You better not simplify, not distribute cosine theta in denominator. Okay, left side is same. And then, according to Pythagorean identity, you can replace 1 minus sine squared theta to cosine squared theta, because cosine squared theta plus sine squared theta is equal to 1. Okay, so numerator cosine squared theta, denominator cosine theta times 1 minus sine theta. Left side, you keep same expression. Now you can divide the numerator and denominator by cosine theta in right side. Cancel out, cancel out. So numerator is cosine theta, denominator 1 minus sine theta, which is same as left side. Alright, let's try one more. 43. (43) 1 plus cosine theta over sine theta plus sine theta over 1 plus cosine theta is equal to 2 cosecant theta. Whoa, very complicated. Left side is more complicated, so let's change left side by addition. I'm going to add those two fractions by setting up common denominator. So common denominator should be product of these two, sine theta times 1 plus cosine theta. In first numerator, you have to multiply that one. So 1 plus cosine theta times 1 plus cosine squared theta, which is 1 plus cosine theta squared, plus in second numerator you multiply that one, so sine squared theta. You keep left right side as it is, and then you simplify numerator. 1 plus 2 cosine theta plus cosine squared theta plus sine squared theta over denominator, just keep it sine theta times 1 plus cosine theta. In numerator, as you can see, cosine squared theta plus sine squared theta. There is cosine squared theta plus sine squared theta, which is equal to 1. So 1 plus 1 is 2. Right? 2 plus 2 cosine theta over sine theta, 1 plus cosine theta. Is equal to 2 cosecant theta, right side should be same. And then in numerator you factor 2 out, because in these two terms 2 is common factor. Take 2 out, it's like factoring cosine theta over sine theta times 1 plus cosine theta. The other side is 2 cosecant theta. Now you can cancel out common factors, 1 plus cosine theta in numerator, 1 plus cosine theta in denominator. So on the left side, 2 over sine theta is left. Right side is 2 cosecant theta. Finally, you can change 1 over sine theta to cosecant theta based on reciprocal identity. So it's going to be 2 cosecant theta, which is equal to 2 cosecant theta.